To better understand, let's take a scenario.
Suppose you have a two router with a PC connected in each. You've given a unique IP so that they belong to a different network. PC1 lies within a network of 192.168.1.0 and the PC2 is in the network of 10.0, both of which have the same subnet mask of /24. You've set up the default gateway and also managed to connect both routers with the proper IP addresses from the 172.16.0.0 network. Keep in mind, each of these devices is a part of a different private network. Now that the connection is set up, when trying to ping between the devices, the ping failed. But what happened? Through the simulation mode, we can see the router A didn't forward the packet to the router B. Because router A only knows about the 192 and the 172 networks, it currently has no idea about 10.0 network. That's why when you try to ping a PC with an IP of 10 or something, router A has no idea where it should forward that packet and it just drops it. In this case, the router is not routing, and routing is not possible without configuring proper route in the router itself. Now you have some idea why the routes are necessary. But how do you configure these routes? There are actually two types of routes, static and dynamic. As the name suggests, static route is where the routes are manually configured and it does not change. Our first router cannot forward the packet of the 10.0 network, so we have to configure such as any packet for the network 10 or something with the subnet mask of /24 should be sent to the 172.16.0.2, which is this interface. Similarly, router B does not know about the 192 network, so the route has to be added such as any packet for the network 192.168.1.0 with a subnet mask of /24 should be sent to the 172.16.0.1, which is this interface. Up to this point, router A knows about the 192 and 172 network since they were directly connected, and it learned about the 10.0 network through our static routes. Similarly, router B knew about the 172 and the 10.0 network as it is directly connected, and it learned about the 192 network through our static routes. Since our static routes are set, let's try pinging now, and it is a success. Static routing is cool. However, rather than telling each router about all the existing network of the topology, what if routers could talk to each other and share all the information themselves? And this is exactly what dynamic routing protocols do. OSPF, EIGRP, RIP are some of the examples that you may have heard. Using such protocols, routers share their routing information with other routers and update their own if required. Each of these protocols have their own way of working. However, they try to achieve the same common goals. 1. Share the network information with other routers. 2nd, periodically check for changes in the link. And 3rd, update the routing link if necessary. Some protocols such as OSPF and EIGRP uses an algorithm to find the best available link possible. Static routing is simple. It doesn't rely on any other protocols for routing decision and is often best for the small networks. It is fast, uses less bandwidth and has no overhead. It is also easier to perform administrative tasks, especially in a scenario where multiple paths are available for a single node. But it all comes with some cons. Static routing may be best for the small network. However, in a large network, the number of routes increases exponentially. So the scalability option is limited and also more prone to human error. Paths are already fixed, which means router may not utilize the best available link for the data transmission. And finally, maintenance is a hassle. If a router needs to come offline, someone has to manually configure alternative routes in order to achieve the desired routing. The disadvantages of the static routing is generally an advantage for the dynamic routing protocols. With less chances of error, it scales rapidly while also utilizing the best available link. Similarly, maintenance isn't a big problem since the routes get rerouted automatically. However, dynamic routing protocols use complex algorithms which take some time to configure itself, making it somewhat slow compared to the static routes. My recommendation would be, if your network is small and there is less chance of rapidly growing it, use static routes. But if you want your network to scale, just stick with dynamic routing. Personally, I prefer the dynamic routing protocols just because I'm lazy.